Vectors and scalars. In this physics tutorial, you will learn 1. What are vectors? What are scalars? 2. How do vectors and scalars in physics differ from those in mathematics? 3. How can we express a vector quantity in components? 4. How to find the magnitude of a vector quantity when the components are given? 5. How to find the angle formed by a vector with a certain direction. Introduction. Let's consider the following scenarios to understand the point. 1. Your cousin has just arrived in your city. She calls you and asks to come and pick her up with your car. When you ask her for the location, she replies, "I am 2 kilometers away from the city hall." 2. Your father tells you to pull out the dining table, as he wants to make place for plant pot. 3. You are lost at sea during a trip with your ship. You don't have any mobile phone, radio or other tools of communication but only a map and a compass. 4. You are told to kick a ball in a given direction but you are not able to see the person who told you to do so. Is the information provided above complete? Do you need to know any other thing in each of the above scenarios? Vectors and scalars. Let's try to understand what is wrong with the situations described above. 1. The information is incomplete, as your cousin didn't provide any direction. You cannot hang around the city to find her, despite she has informed you that she is at 2 kilometers away from the city hall. Indeed, she may be anywhere in the circle whose center is at the city hall and whose radius is 2 kilometers long. 2. The information is incomplete. Your father didn't tell you the direction in which you should pull the table. There are many possible directions to pull the table. 3. The first thing to do in this case is trying to find the directions using the map and the compass. Then you can sail in the correct direction. 4. In this case, you need to know whether you have to kick the ball gently or strongly. The person may be near or far away, so you have to know how to kick the ball despite already knowing the direction. In all these examples, there was some missing information. It was missing either the magnitude or the direction of the action you had to do. Therefore, it is quite impossible for you doing what you were told to. The concept of vector helps you to understand the point. A vector is a quantity that has both a magnitude and a direction. If one of them is missing, the information is incomplete. Geometrically, a vector is represented through an arrow. The tip shows the direction and the ending point, while the toe shows the starting point of the vector. Symbolically, the vector is denoted in 2 possible ways: 1. By 2 uppercase letters where the first letter shows the starting point and the second one the ending point of the vector, or 2. By a single lowercase letter at middle of the vector. Also, a small arrow must be placed above the letters, representing the vector to distinguish it from a segment. Look at the figures shown on screen. On the other hand, a quantity which has only magnitude, meaning it does not involve direction, is known as scalar. For example, real numbers are scalars. You simply need to know their numerical value to have a complete information regarding the quantity involved. For example, we know that 5 is greater than 3 because we compare the magnitudes of these 2 numbers. Vectors and scalars in physics. All quantities in physics are either vector or scalar. For example, force is a vector quantity as it involves direction. As discussed in the introduction section, it is not sufficient to know only the magnitude or only the direction when trying to move something by exerting a force. We must know both the magnitude and direction of force to understand what to do exactly. On the other hand, temperature is a scalar quantity because it doesn't involve any direction. It doesn't make sense if we say the temperature today is 30 degrees Celsius due north. We simply say, the temperature today is 30 degrees Celsius. However, quantities in physics require more info compared to those in mathematics. If in mathematics a vector quantity is fully known when two clues magnitude and direction are given, in physics we must also know the unit and the application point besides the two above-mentioned clues. Let's explain this point through an example. We will mention here the unit of force, Newton, whose symbol is N, to illustrate the example. Example: you are told to move the object shown in the figure. This is an upper view of the object. It is not sufficient if you are told pull the object due east. In this case, there is insufficient information, as you are not told the magnitude of the force to be used / how many Newton of force must be used. Also, it is not sufficient if you are told pull the object by 50 N, as no direction is mentioned. Finally, it is not sufficient if you are told pull the object by 50 N, due east because no application point is provided. The person who told you to pull the object must also tell whether the force must be used at center or at the edge of the object, as the outcome will be different. Thus, if you pull the object at its center, it will move like this. But, if you pull the object by picking it at the edge, the result will be as shown. In the first case, the object will make only translational motion, known as parallel shift, while in the second case there will be a combination of translational and rotational motion as the object first starts rotating and then it moves linearly. The differences between vector and scalar quantities in maths and physics are summarized in the table shown. Components of a vector. It is not always the case that the direction of a vector coincides with one of the main directions we use as basic ones, such as up, down, left, right, or north, south, west, east. Vectors can also lie in such directions that are combinations of these four basic ones, such as the vector shown in the figure on screen. The direction of the vector, A, B, is neither due east, nor due north, but it is a combination of these two basic directions. Therefore, we can provide info about the horizontal and vertical shift of the point, B, in relation to the point, A, if the vector, A, B, is not visually shown. In this way, you will enable the listener drawing the vector if he wants to. For example, if you say, the point, B, is 4 units on the right and 3 units above the point, A, your partner will easily draw the vector, A, B, as shown on screen. In this way, the vector, A, B, splits into two components, the horizontal, X component, and the vertical, Y component, as shown on screen. It is not easy to find the length/magnitude of the vector, A, B, when it does not lie according to one of the main directions, especially when you don't have any measuring tools and when the only information you have is the horizontal and vertical units. From the figure shown on screen, it is obvious that when splitting a vector into components, a right triangle is obtained. These components, namely, A, B, X, and A, B, Y, are those which form the right angle, and the vector, A, B, itself is the hypotenuse of the right triangle. From the Pythagorean theorem, we get therefore, the magnitude of the vector, A, B, is as shown on screen. It is not necessary to write the vector symbol above the components. Also, the symbol as shown on the text on screen stands for the magnitude of the vector. It mathematically represents the absolute value of the quantity it contains. This is because the vector can lie to the negative direction, but its magnitude is always positive as it represents the vector's length. Let's explain this point through some examples. Example 1. The horizontal and vertical components of a force are f x equals 120 n, and f y equals 160 n, respectively. What is the magnitude of the force F? Solution 1. The components of a vector, in the specific case, we have a force vector, have their starting point at the starting point of the original vector itself. However, for practical purpose, we can shift the vertical component, F, y, in a parallel way in order to close the triangle. From the Pythagorean theorem we have Therefore, the magnitude of the force F is as shown on screen. How to find the angle formed by a vector with a certain direction? Where theta is the angle formed by the adjacent side and hypotenuse. These rules can also apply in vectors. They help us find the direction of a vector quantity. We simply replace A with V, x, B with V, y, and C with the vector V, whatever it may represent. Example 2. An airplane moves 44 km due north and then 76 km due east. Calculate 1. The total displacement of the airplane. 2. The angle formed by its displacement vector to the west, east direction. Note, displacement is a vector quantity. Solution 2. The airplane's flight is graphically described in the figure shown on screen. It is obvious the angles theta are both equal as they are alternate interior angles. Therefore, we can limit our study by considering only the right triangle. The two given values, 44 km and 76 km, are the components of the displacement vector as they are perpendicular to each other, and furthermore, they lie according the two basic directions. Thus, we have Despite the displacement due north has occurred first, we can switch the position of the addends due to the commutative property of addition. Substituting the values, we obtain. Here, kilometers squared does not stand for any surface area but only because we raise the displacements at power 2. Therefore, the total displacement will be. This value represents the shortest path from the initial to the final position of the airplane. As shown by the gray vector, we can use the trigonometric equations to find the required direction. The direction is considered as known if we find the angle, theta, formed by the displacement vector to the west-east direction. Here it is similar to the x-axis. Thus, when considering the triangle formed in the graph, we obtain. Therefore, the angle theta is as shown on screen. Hence, the airplane is 87.8 km away from the starting position and its displacement vector forms an angle of 30.07 degrees to the west-east direction. This information is particularly useful when the pilot provides his location during the communication with the air traffic control center during the flight. Summary. A vector, in mathematics, is a quantity that has both a magnitude, numerical value or size, and a direction. If one of them is missing, the information is incomplete. Geometrically, a vector is represented through an arrow. The tip shows the direction and the ending point while the toe shows the starting point of the vector. On the other hand, a quantity which has only magnitude, does not involve direction, is known as scalar. For example, real numbers are scalars. You simply need to know their numerical value to have a complete information regarding the quantity involved. All quantities in physics are either vector or scalar. For example, force is a vector quantity as it involves direction, while temperature is a scalar because only its numerical value is required. However, in physics, vectors and scalars are different from those discussed in maths. The table shown on screen sheds light at this point. Not all vectors lie according the known basic directions. Hence, it is better to split them into components to ease their study. In this way, any vector, A, B, splits into two components, the horizontal, X, component, and the vertical, Y, component. Magnitude of a vector, A, B, represents its length in the given units. We can use the Pythagorean theorem to calculate it. Thus, to find the angle formed by a vector with a certain direction, we use the following trigonometric formulae, where theta is the angle formed by the adjacent side and hypotenuse. For vectors and scalars revision questions, visit our website via the link in the description. Thank you for watching.